Okay, so mean value theorem says instantaneous rate of change, which would be derivative. You okay with the derivative? And you remembered the 2 for the chain rule? Okay. Is equal to the average rate of change, which is like the slope formula, at least once if the function is continuous and differentiable there. So no breaks in the graph, no sharp sudden turns like a cusp. So we get 2 cosine 2x is equal to, we plug in pi over 2. Pi over 2 times 2 would be pi. What's the cosine at pi? Okay. Times that by 2. Plug in 0. The cosine of 0 is 1 times 2. Wait, hold up. Yeah. Yeah, that's what I was figuring out. I plugged this into the derivative for some reason. I should be plugging it into the function. So the sine of pi is 0. The sine of 0 is 0. So you get 0 over pi over 2, which is just 0. So the instantaneous rate of change, which is derivative, is equal to the average rate of change, which is 0. Be careful that you're plugging the numbers in the right spot. Don't plug them into the derivative like I almost did. You could divide both sides by 2. Bless you. Okay, and now we have to think about what numbers between 0 and 2 pi times 2 give us a cosine of 0. Okay, so you could maybe do that with guess and check. It'd take you a little bit longer. But the way I would describe this in a pre-cal class is pretend like it just says cosine x equals 0, and think about that on the unit circle. Where's cosine 0? Okay. On the y-axis, when x is pi over 2 and 3 pi over 2. But then you just have to go back and add a step. This wasn't really an x, it was 2x. So I didn't solve for x, I solved for 2x. So divide both sides by 2. X could be pi over 4 or 3 pi over 4. But the question said our domain was 0 to pi over 2. So that one's outside of the domain. Only that one's inside the domain. You see where you went off there?